So a family of graphs is a group of graphs that display one or more similar characteristics. That should be easy to remember, because doesn't your family members usually share some characteristics? Maybe they look alike or act the same. So think family, similar characteristics. Family graphs have one or more similar characteristics. The parent function is the simplest of graphs, the simplest one. And this is the graphs that we're going to be transforming today. We're only having to look at 3 parent graphs, so you only have to memorize 3 for your test on Friday. And these are the 3 that I'm talking about: constant, identity, and absolute value. And the way you are going to memorize them or identify them is just by looking at graphs and being able to tell, is this a constant function, identity, or absolute value? Well, constant's easy to tell because it's always going to be what type of line? Horizontal. Always going to be horizontal. So the format of this will always be y equals what? 0 or any number, right? Constant. Identity function is easy to identify because this is what type of line? Linear. Good. Is a straight line with a slope other than what? 0. Good. So slope m is not 0. And then the identity function, or excuse me, the absolute value function is easy to identify because it'll always have the shape of a what? A V. Good. V shape. So on your test, this is how like one of your questions will look. It'll say identify the type of function. So you would tell me this is what type of function? Yeah. Easy as that. Absolute value function, I knew that because of the V shape. And this is what type? Constant. And this is what type? Identity. Very good. Easy enough. So that was learning target 27. I can identify parent functions. Alright, you'll flip it over. This is what you'll have to memorize. Mainly this part. But like I said, we're going to work it so much today you'll have it memorized. Okay? There's 3 types of transformations. There's a translation, a reflection, and a dilation. The translation, these 4, is when we're adding or subtracting something to our function. Adding or subtracting. That's called a translation. These 2 are kind of look alike, right? Both of them are adding 8 to our function. Just one of them is negative, one of them is positive. This is going to be translating our function horizontally, which means in which direction? Which is what? Left to right. Good. So put left to right. And that's if the h, or the number, is inside grouped with the x. So put grouped with x. That's when it's moving left to right. When it's grouped with the x, added or subtracted. Alright, if it's not grouped with x, so not grouped, it's just being added to the outside like this k is, it's going to be moving it vertically, which is what? Up and down. Good. So the first thing we're going to do is just focus on translations. Once we've mastered that, then we'll move on to reflection and dilation. So again, translations only when we're adding or subtracting. So for this number 1 down here, notice this 4 is being added to this function. Is it grouped with x or is it on the outside? It's on the outside. Good. It's not grouped inside this absolute value bars. So it's moving it which direction? Up or down. And the plus makes you think it's going to move it what? And you'd be correct. So here's how we describe it. First we need to name the parent function. What's the parent function of this? Good. Absolute value of x, that's the parent function, is being, what's that word? What are these called? Translations. So it's being translated. How many units? 4. Good. Units. And which direction did y'all say? up. Very good. So just to clarify, the translated is because we added or subtracted something to it. That's called a translation. The 4 came from the number, and then up is because it's on the outside away from x and it's a plus sign. Does everybody see that? All right, flip it over. So this one, kind of a different look. Do you think this 5 is grouped with the x or not grouped with the x? What makes you say that? It's not in parentheses or absolute value bars, right? So it's on the outside, away from x. So it's going to be moving which direction? Up or down or left and right?
Down.
Up and down. And why'd you say down? Good. So we would say, what's the parent function? Y equals x. Good. And we put what? Translated. 5 units. In which direction? Down. Very good. Any questions on that one? All right, number 3. Is that 3 grouped with the x or on the outside? Grouped with. So it's moving it in which direction? Left or right? What do you think it would be moving? Which direction? Right, because it's positive, right? Well, x is a joker. Anytime the number is with x, it's the opposite. Think of your ex-girlfriend or boyfriend. They're always trying to get you in trouble and make you do the wrong thing, right? Don't lie, I know they are. So think of your ex, okay? Everything that is with your ex, when you're with your ex, it's the wrong thing. So it's not moving it right. It's moving it which way? Left. And let me further explain why. This is not on your paper. I just want you to try this one along with me out loud, okay? Let's say that we are going to graph the line y equals 2x. Okay, I'm going to graph it on here. First of all, for y equals 2x, what's my y-intercept? 0. And my slope is what here? 2. So I'm going to graph this. I'm going to start at 0, then go use my slope to move. And here's the line y equals 2x. Would everybody agree? Now I'm going to move all these points that I just drew. It says 4 places. It says to the left. I marked it out. 4 places to the left. I'm going to use a different color so you can see the difference. So to the left, 4 places. 1, 2, 3, 4. I'm going to move this dot. 1, 2, 3, 4. Move this dot. 1, 2, 3, 4. And this one also, and this one also. And I'm going to draw the line. Oops. And now let's think of the equation for this line. To write an equation, we just need the slope and y-intercept, right? Where does it look like the orange line's crossing the y-axis at? 8. And what's the slope? 2/1 doesn't change, right? So that's the equation on my orange line. Would everybody agree? Alright, now let's factor out what these two have in common. What do they have in common? A 2. So tell me what to write if I factor it out. 2 parentheses. Doesn't that look like a translation? And it's on the inside with x, so we know it's moving it left to right. This says +4, but I moved in which direction? Left. So just remember that when it's with x, it's a joker. You'll move the opposite way of what you're thinking, okay? Alright, back to the sheet. So tell me how to write the description. Just the parent function. So absolute value of x, and then I would write, what's this called that we're describing? Translation. So translated. How many units? 3 units. Which way? Good. Does that make sense? And how did I know that I was moving left to right instead of up and down? Yes.
Why would you put 3 with it if it was in the absolute value?
This is the transform graph. The parent graph is the absolute value function, which is just y equals absolute value of x. Alright, I want you to try, circle these for me, 5, 6, and 7 with your group. Now, notice that this has some numbers out front, some negatives. I don't want you to worry about that. Does anyone have a highlighter with them? Can I borrow that? Oh, bad catch, sorry. Let me come get it. The only part I want you to focus on describing are the translations, which is this part, this part, this part, this part, this part. Go ahead and do that with your group. Describe that. Make sure you talk to each other. So don't worry about the numbers out front. We'll get to that in a minute.
Yes.
Translations are only when that and subtracting that. So that 6 is being multiplied, right? You're just describing the adding and subtracting. Okay.
Wait, we did this one. No, we didn't.
This one?
Yeah, we did. We're going to be up one.
You did it right. On the outside, when it's not with X, it's moving up and down. It's on the inside, it's left, right. Alright, let's go over these. So, when I call on y'all's group, if you'll just tell me what you wrote for this one. So, starting with Sid, what y'all have for this one?
We had y equals absolute value of x translated down to
units. Would everybody agree? And how do we know it's up and down?
because the -2 is not repeated.
Very good. Does everybody see that? Okay. Amy, what y'all have for this one?
Y equals absolute value of x. Translated to unit right. And greater than
Is this correct? Yes. Any questions about that? And how did I know that this 1/5, that it didn't move it up or down or left or right? It's being multiplied. Translations are only when you do what? Add and subtract. So right here, Caleb, describe what y'all had for this one.
Y equals the absolute value of x. Translated left 2 units and down 4.
2 left and down 4. Does everybody agree? Yes? Alright, so how do y'all feel about translations? Pretty easy? Okay. Flip it over. So now we'll talk about reflections. This is another type of transformation, a reflection, and it's only dealing with when you have negatives, right? Negatives. So reflections is only when there's a negative. Not minus, but when there's a negative out front of your function. Now, if it's outside of your function, outside, so that means not grouped with x, then it's going to reflect across the x-axis. And we'll talk about what that looks like in a minute. If it's on the inside of your function, so that means it's grouped with x in either parentheses or absolute values, so inside, it's going to be flipping across your y-axis. So here's what I'm talking about. Let's say that we have the parent function for absolute value. That's this one. What's the equation for the graph I just drew? Y equals what? Good. If it was on the outside, so y equals negative absolute value of x, it's on the outside, away from it, it's going to be flipping across which axis? X-axis. Okay, that's this one, right? So when I flip it, it's just taking it and flipping it upside down. So this is what it would look like. Okay? If it was on the inside, like this, it would be flipping across which axis? The y. This is our y-axis. What would happen if I flipped it? Would it look the same? Yeah, because it is the same. Because anything we take out of the absolute value bar is going to be what? Positive. Now let's say if I had like the identity function. This is the identity function, right? Y equals x. Let's say that it was on the inside. So y equals negative x. That's going to flip across the y-axis. So it would be right here and flip this way. Does everybody see the difference of flipping across the x and y? Alright, so now let's describe that. I think there's only one of them on your paper. Which one involves a reflection? Which number? 5. Good. And y'all describe it. It's going to be reflected across which axis? How do you know? Good. It's away on the outside. So you would write y equals absolute value of x reflected across, and Sid, you said which axis? Does everybody agree? X-axis. So everybody's good with the reflections, right? Sorry, I gave you only one example. You'll have some more later. So now let's look back. Let's talk about dilations. This is the last type of transformation there is. And this is if we are multiplying by a number. This is if we're multiplying your function by a number. Now, the number can be on the outside like this one is, not grouped with x. So if it's on the outside, away from x, it's going to be moving or changing vertically. And stretching vertically means the graph's doing what? It's stretched vertically. If I stretched Simon vertically, he would become what? Taller. If I compressed him vertically, he would become shorter. Okay? And then horizontally, if I compress someone horizontally, they would become what? Skinnier. And if I stretch them horizontally, they would become larger. Okay? So that's how it would look on your graph. Now if it's on the inside, grouped with x, it's going to be changing it horizontally, side to side. So let's look on the back. Which ones contain a dilation? Tell me what numbers out loud. 6, 7, any other ones? 4, is that all? Yes. Those are the only ones with dilations. Now let's look closer. Number 4. What is the number we're focused on? 4. And is it grouped with x or is it on the outside? Grouped means there would be what? Parentheses or absolute value bars. So is this grouped with x? Nope, it's on the outside. So let's look back. If it's on the outside, now these come in handy. It says if the number a is greater than 1, then it's going to stretch it vertically. If it's between 0 and 1, so that's talking about what type of numbers? Fractions or decimals. It's going to compress it vertically. The number we were focused on was what? 4. So it would fit into what category? The top, because 4 is greater than 1, right? So that 4 is going to do what to our graph? stretch vertically. So here's how we write it. What's the parent graph? Y equals what? X stretched which way? Vertically. That's it. Which means that 4 is going to make it taller. And we could have guessed that because what is this 4? It's the what? The slope. And if we go up 4 over 1, isn't that going to make it taller? Alright, try these two with your partner. Describe the dilation for me. Alright, the number we're focused on is what? What are we multiplying by here? On number 6. Yep. Because these are being subtracted. This is the only thing being multiplied, right? Is it on the inside of X or on the outside? Alright, so flip your paper over. So we're looking for on the outside. So it's got to be one of these two. And the number we were focused on was what? Good. So is 1/5 greater than 1 or between 0 and 1? So it would vertically. So now for the next one, try to figure that one out. Alright, so Evan, I already called on y'all's group, sorry. Darius, what y'all have for number 6?
Y equals the absolute value that comprise variable.
What do y'all think? Do y'all have the same thing? Yes? Because the 1/5, is it on the outside or inside? Outside, and it's between 0 and 1. Any questions on that one? Alright, Connor, what y'all have for the last one?
Y equals the absolute value of X stretched horizontally.
Stretched horizontally. Does everybody agree? What'd y'all put? Compressed? Alright. First of all, this is on the what? Inside or outside? Because it's grouped with X, right? So if we look on the inside, and A is what in our case? What's the number? 6, right? So it's on the inside, sorry. And it's 6, which is greater than 1. So that's going to do what? Compresses horizontally. Very good. Any questions on those? Yes.
So if you were to have a fraction that would be like 6/5, that would be stretched, right?
Is 6/5 greater than 1 or less than 1? Yes, so it would be the same as this one, compressed. You're talking about on the inside or outside? Outside, then it would be the same as this one, stretched vertically. Does that make sense? Okay. Any other questions on these? Alright, you will not have this for your test. So these are pretty easy to memorize. These are the only ones that you'll really have to study, pretty much. Okay. Now we're going to use these to graph it. So the first thing I want you to do on all of these graphs, or at least for the first few, is graph the parent function first. And what is the parent function of this one? Y equals. That's what we're going to graph first, and I want you to put parent graph, PG. Alright, there's a bunch of different ways we can graph this one. You can type it in your calculator, you can make a table, Or you can just look at the very first page, and this is always how your parent graph will look for absolute value. Okay, so which one y'all want to do? Just look at this. Okay, where's the center at? Go ahead and draw a dot at 0, 0. And I'll just show you a shortcut. What's the number in front of x? 1. So that's going to be your slope. So from here you'll just go up 1 over 1, up 1 over 1, up 1 over 1, and now I just need to do what on this side? It's got to be a V shape, we know that. So don't I just copycat these points on the other side? I want you to draw that in either pencil or pen or whatever color, but you're going to do your transform graph in a different color. Make sure you put beside parent graph that this is the color you used, so you can keep up with that. And now, remember how I showed you this example where I moved every point just 4 units to the left? What is this transformation saying we're going to do? What is that 3 going to do? 3 units which way? Left. Everybody remember that? So all you're going to do is move all of the points you just drew 3 units to the left. So this is how it should look. Take 0, 0, move it 1, 2, 3 to the left. This one, 1, 2, 3. This one, 1, 2, 3. Go ahead and draw your transformed graph. Can anybody think of an easier way than moving all the points? Nobody? Will the center of your parent graph always be 0, 0? Of your parent graph? Yeah. So couldn't you just take 0, 0, move it 3 places to the left, and just use your slope to move? Okay, that's the easier way. Alright, let's look at the next one. First of all, let's talk about what is the transformation being done. So Rihanna, tell me what is being done here. Or first of all, what's the parent graph? And it's being, what's that word? Translated. How many units? In which way? Yes. And how do we know it's down? Because it's what? Not grouped with X, plus it's negative. So it's moving it down. So what I want you to do, go ahead and graph the parent graph in one color, which is the same one we just did on the last problem. And then you'll need to move each point 4 units down. Or you could just move the center. 1, 2, 3, 4, and then go what? Up 1 over 1, up 1 over 1. Try 3 with your partner. Number 3. So think about what's being done, then graph your parent graph and your transformed graph. of transformations being done. Reflection. Over which axis? Very good. So here's the parent graph. If I flip it across the x-axis, it's just going to do what? Turn it upside down. Good. So same point, 0, 0. But all of these points are just going to be flipped the other way. Also, what's the slope of this one right here? -1. So you could have just gone to 0, 0, then down 1 over 1, down 1 over 1. Does everybody see that? Alright, questions about that one? Try the next one. Then go parent graph first. Take that point at 0, 0, put your pencil on it, and now you're going to move it 1, 2, 3, and draw a dot. And now your slope's just still going to be what? Yes. Does that help? You get what I'm doing? Alright, if you have done number 4, try 5. Just number 5. 4 and 5. And we'll go over it after we try them. So 4 and 5, then we'll go over, and then we'll call it a day. Start with adding and subtracting first, just like we did last time. So draw your parent graph first. Start there. So draw your parent graph first. Stop here. What's your slope? So you would go not down to it's -1. It's right at X, right? Perfect. Yeah. Are you talking about the graph before?
The graph.
Yeah, so graph and what I would do you would calculate it first, and you go left one onto, then use this and slope. And then it's like what? Yes. So once you draw that point, you just go down. Does that make sense? Alright, I need 2 graphs to show under the board. You don't even have to come up, and I just use your graph. Thank you. Alright. This is the graph for number 4. Does everybody agree that this is correct? Check it. And then this is the graph for number 5. What do we think? Very good. Y'all can pack up. No homework. But we're going to start on this number 6 tomorrow. So make sure you have this. Thank you, Madison. Make sure all my color pencils are back in their jars, please.
Coach Horton Bailey said that on the tour whenever we're going to church in the morning.
Chapel.
Yeah.
And they're going to announce your name and make you stand up in front of everybody.
Really?
It's not a big deal.